Okay, so in this lecture, we're going to continue on data cleaning and EDA, right? Exploratory data analysis. Quick review of some of the concepts from before, some of the important data structures within data frames and pandas, and some of the important APIs on that data frame. So we talked a little bit about the kind of data that you might come across, and that's in your EDA process. And these are kind of concepts and keywords that you should learn as a new data scientist. So first one is structure. So it's about how many columns and how many rows. And then there are all these other aspects of the data. Let me see. So next one is granularity. So when we looked at, I think by now, hopefully you guys have started assignment 2. You would have seen the baby names in your data, in that data file for assignment 2. So those actually were not individual records. You actually saw for one particular year how many babies were given that name, Mary, for example, or John. Those are not individual records, right? They're aggregated for that year. So that's the kind of that's what we're talking about, granularity. So when you look at like different kinds of data sets that I pointed to you on the announcements, either at the state or at the city level, and you look at the actual, you try to explore and look at the actual data, you might actually see things like counts, right? And you go, wait, that's not really individual records. That's not something that one person added and submitted into the system. Somebody kind of like said, I did a grouping, and then I'm going to add this data into my database, okay? So that's what it means by coarse or fine-grained kind of granularity. The next one was scope, right? Let me say what it for the census, does it contain, like, for example, all the actual US citizens or households within the United States? Let's say only like 20% of the people actually submit and complete the census. That's not really a full 100% scope, okay? So like I'm interested in studying crime in California, but I have only Berkeley data. So you can, perhaps extrapolate from that. Kind of a bad way of extrapolating, And then temporality, which is the data aspects of the data, right? For the census, you know that it's a snapshot of like 2020. And I think, hang on. And then there are other aspects about the data that has some time aspects. The time zone that was used when it was recorded, and what time zone it was recorded from. If they don't actually put the time zone in the data, then maybe sometimes they'll always use like Zulu or UTC, and they'll put everything in that one time zone rather than putting it into every specific time zone. That way, they know that everything was recorded in UTC, and everybody can then figure out what is the local time from that. There's a other kind of, maybe if you never came across it, which is epoch. So it's like the number of milliseconds since a certain date and time in the past. And that's typically what's used in a lot of computer systems on storing a timestamp in the system, in a database. So this is about the UTC timestamps. So either using a specific time zone or using a central time zone like UTC. So the next part is about faithfulness or missing data, right? So how much of this data is actually trustable, right? Are there going to be misspelling of names, location that doesn't exist? So a lot of these things can happen from data that's entered by hand. And then sometimes they're actually, how you say, falsification of the data, especially when you deal with fraud, right? So if you, I used to work for an e-commerce company, and we noticed patterns of like, Joe1 at hotmail.com, Joe2 at hotmail.com coming in for the like a certain time period. We knew that either somebody was trying to create a bunch of accounts for himself or herself, or we thought it was possibly fraud. And then when you actually look at your data, you might find data that wasn't actually entered. So it might either be a blank space or some value that's not expected. So these are some signs when your data is not faithful. So either things that were not converted into a centralized time zone or a common time zone, or was there some maybe possible truncation of the data? And then could be also about units. So if you have to check with whether you're dealing with metrics or the imperial system in the US, right? And then you have to then know what to do when you have either missing or bad data, whether you should drop the records or you should do something called imputation, which is you're kind of guessing what, or doing something with the data to hopefully, let's say, give you an example. If there was a census on campus and you had to enter your age, and let's say 25% of the survey data actually received, the age was not entered. Well, if you were to remove 25% of your collected data, you would lose a lot of important data. So instead of deleting all those records, you can take an average of your other existing age and then enter that average for all the fields that have missing age. And that's what we call for, the imputation. That way, all your other fields would not be lost in your data. And you might need all that other data for building and training and testing your models. Okay, and last thing is about revisiting your sample and seeing whether is it really a good sample, because you're not going to be able to collect all the data for your population, let's say for the US Census. And so whether you need to go get a new sample or you need to look for more data sets, you have to then do that kind of you have that decision point. So this is important for like when you're doing your project and you're looking for data, you have to look at the data, start analyzing it and seeing whether it's actually good data.